The cosmos, in its vast expanse, holds countless wonders. It stretches beyond our imagination, filled with stars, planets, and galaxies that have yet to be explored. Each twinkling star represents a potential new world, a new frontier for humanity to discover. Among them is the tantalizing possibility of life beyond Earth. Could there be other beings looking up at their skies, wondering if they are alone? The search for extraterrestrial life drives much of our exploration, pushing the boundaries of science and technology. As we venture further into space, the question arises, what would humans look like on other planets? Would we evolve to adapt to new environments? Or would we use technology to change our surroundings to suit us? The possibilities are endless and fascinating. How would our bodies adapt to alien environments? The low gravity of Mars or the intense pressure of Venus would challenge our physiology in ways we can only begin to imagine. Scientists are already studying how space travel affects the human body, providing clues to how we might survive on other worlds. Let us embark on a journey to two of our closest planetary neighbors, Mars and Venus, to explore the fascinating realm of human adaptation. Mars, with its cold desert-like landscape, and Venus with its thick toxic atmosphere, present unique challenges and opportunities for human colonization. Our species has always been shaped by its environment. From the lush forests to the arid deserts, humans have found ways to thrive. Our ability to adapt is one of our greatest strengths, allowing us to survive in a variety of conditions. From the scorching deserts to the icy poles, humans have proven remarkably adaptable. We have developed technologies and strategies to cope with extreme heat, cold, and everything in between. This adaptability will be crucial as we look to settle on other planets. But the challenges posed by other planets are far greater. The lack of breathable air, extreme temperatures, and high radiation levels are just a few of the obstacles we must overcome. Training underwater and in other extreme environments on Earth helps prepare astronauts for these challenges. On Mars and Venus, we encounter worlds of stark contrasts, each demanding unique evolutionary responses. Mars, with its potential for underground water reserves, and Venus, with its possibility of floating cities above the clouds, offer intriguing possibilities for human habitation. The future of humanity in space is a universe of possibilities waiting to be explored. Mars, the red planet, has long captured our imagination. From ancient civilizations to modern science fiction, Mars has been a symbol of mystery and possibility. Its striking red color, visible even to the naked eye from Earth, has inspired countless stories and theories about what might lie on its surface. Its rusty hues and hints of ancient water suggest a world with the potential for life. Scientists have discovered signs of ancient riverbeds and dry lake beds, indicating that water once flowed on this, now arid planet. These findings fuel our curiosity and drive our quest to uncover the secrets of Mars's past. While current conditions are harsh, Mars remains the most hospitable planet in our solar system for human colonization. The thin atmosphere, composed mostly of carbon dioxide, and the extreme temperatures present significant challenges. However, with advancements in technology and human ingenuity, we are closer than ever to making Mars a second home. But what would it take for humans to thrive on this alien world? Establishing a sustainable colony on Mars would require overcoming numerous obstacles. We would need to develop habitats that can protect us from radiation, create systems to produce food and water, and find ways to generate energy in an environment with limited resources. The journey to Mars itself would be a testament to human ingenuity. Traveling millions of kilometers through space, astronauts would face a long and perilous voyage. The spacecraft would need to be equipped with life support systems, radiation shielding, and supplies to sustain the crew for the duration of the mission. Confined within spacecraft for months, our bodies would begin to adapt to the weightlessness of space. Astronauts would undergo rigorous training to prepare for the physical and psychological challenges of long-duration space travel. The lack of gravity would affect their muscles, bones, and overall health. Bone density might decrease and muscles could atrophy. To counteract these effects, astronauts would need to follow strict exercise regimens and undergo regular medical checkups. Research on muscle and bone density in space is crucial to ensure the health and well-being of the crew. These initial changes offer a glimpse into the profound transformations that await us on the Martian surface. Once on Mars, astronauts would face a new set of challenges, from adapting to the lower gravity to exploring and studying the Martian environment. Each step we take brings us closer to understanding and eventually thriving on the Red Planet. One of the most significant differences between Earth and Mars is gravity. While Earth has a gravitational pull that we are all accustomed to, Mars presents a unique challenge with its significantly weaker gravity. Mars's gravitational pull is only about 38% that of Earth's. This means that objects on Mars weigh much less than they do on Earth, which can have profound implications for human physiology and daily activities. This reduced gravity would have a dramatic impact on the human physique. In a low-gravity environment, the human body would not need to exert as much effort to move or lift objects, leading to significant changes over time. Over generations, Martian colonists might evolve to be taller and leaner than their Earth-bound counterparts. The reduced gravitational force would allow bones to grow longer, and muscles to become less bulky, resulting in a more elongated physique. Gravitational pull on Mars would also affect our muscles and bones. Without the constant resistance provided by Earth's gravity, our muscles might not develop as robustly, and our bones could lose density, becoming more fragile over time. With less resistance to work against, our muscles might atrophy, and our bones could become less dense. This phenomenon has been observed in astronauts who spend extended periods in space, where they experience muscle loss and bone density reduction. To combat these effects, Martian colonists would need to engage in rigorous exercise routines and potentially rely on technological aids, such as exoskeletons, to maintain their physical strength. These exoskeletons could provide the necessary resistance to keep muscles active and bones strong, simulating the effects of Earth's gravity. Additionally, advanced exercise equipment designed specifically for low-gravity environments would be essential. These machines could offer variable resistance and simulate different gravitational forces, helping colonists maintain their physical health. Ongoing medical research would be crucial to understand and mitigate the long-term effects of living in reduced gravity. Scientists would need to continuously study the physiological changes and develop new strategies to ensure the well-being of Martian settlers. As humanity embarks on this new frontier, adapting to the Martian environment will be a complex but fascinating challenge. The evolution of the Martian physique will be a testament to human resilience and ingenuity in the face of extraterrestrial conditions. Mars's thin atmosphere offers little protection from the sun's harmful radiation. This constant bombardment of cosmic rays poses a serious threat to human health, increasing the risk of cancer and other radiation-related illnesses. To survive on Mars, humans would need to adapt, both physically and technologically. One possibility is that Martian colonists could evolve darker skin pigmentation. Melanin, the pigment that gives our skin its color, acts as a natural sunscreen, absorbing harmful UV radiation. Over time, natural selection might favor individuals with darker skin, who are better protected from the sun's rays. Section 5. Beyond the spacesuit. Dangers on the Martian surface. Stepping outside without a spacesuit on Mars would be, well, fatal. The thin atmosphere, composed primarily of carbon dioxide, would offer no breathable air. The lack of atmospheric pressure would cause our blood to boil, and the frigid temperatures would freeze us solid. Survival on Mars depends on our ability to create artificial environments. Inside habitable structures, we would need to recreate Earth-like conditions, with breathable air, controlled temperatures, and protection from radiation. These self-sustaining habitats would be crucial for human survival on Mars, providing a safe haven from the planet's unforgiving exterior. Section 6. Venus, a planet of extremes. Venus, our other planetary neighbor, presents a far more challenging environment. With surface temperatures hot enough to melt lead and an atmosphere choked with carbon dioxide, Venus is a hostile world. Human survival on Venus would require extraordinary technological advancements, and perhaps even more radical adaptations. The intense heat of Venus would necessitate specially designed habitats, perhaps even floating cities in the planet's upper atmosphere, where temperatures are slightly cooler. These habitats would need to be completely sealed, protecting inhabitants from the crushing atmospheric pressure and the searing heat. Section 7. Technological marvels, enabling survival on Venus. Given the extreme conditions on Venus, technology would play a pivotal role in human survival. Advanced spacesuits capable of withstanding the intense heat and pressure would be essential for any exploration outside of protected habitats. Innovative cooling systems and radiation shielding would be crucial components of these suits. Beyond spacesuits, we would need to develop technologies capable of extracting resources from Venus's atmosphere and surface. Mining operations, perhaps using robotic probes, could provide us with the raw materials needed to build and sustain a human presence on this unforgiving planet. Section 8. Human Evolution, a Cosmic Dance. As we venture further into space, the question of human evolution takes on a cosmic dimension. The challenges posed by alien environments could drive the evolution of new human species, each uniquely adapted to their planetary home. The Martian colonists, with their taller, leaner frames and darker skin, might be just the beginning. This cosmic dance between humanity and the universe is a testament to our adaptability and our unquenchable thirst for exploration. As we push the boundaries of our understanding and our technological prowess, we open ourselves to a future filled with infinite possibilities. Section 9. Conclusion, Our Future Among the Stars. The cosmos beckons, inviting us to explore its wonders. As we journey to other planets, we will encounter challenges that test the very limits of human ingenuity and adaptability. But within these challenges lies the potential for extraordinary growth and evolution. The future of humanity among the stars is a tapestry woven from exploration, adaptation, and the relentless pursuit of knowledge. As we venture further into the cosmos, we carry with us the potential to not only discover new worlds but to discover new facets of ourselves.